I know we still have another minute, but maybe we can get started. I can talk about the problems that I sent you home with. So there's one we had not graphed, right? That I had asked you to finish up. Were there any issues with that or questions? Huh? No? Yes? Question? No? You forgot? Anyone have a question on it? Yes?
I don't have a specific question. Can we just run through it?
Yeah. So can you remind me? Because I don't have it in front of me. Can you remind me? Hold on, let me get my camera set up here. I can go out to here. Somewhere around there. All right, so I had done the graph, right? Most of it? Where were the x-intercepts?
It was -4, no.
Here, let me look at it. Let me look at it.
I think I did it.
Yeah, -4 and +7.
I grabbed +4 by accident.
But that was your vertical asymptote, right? Is that right? We did all this, right? We did everything except draw it, right?
And do the test.
We didn't do the test points, right? But did I do this part?
Yes.
I did that, right? 2 x-intercepts, 2 verticals.
The horizontal asymptote is 0.
And the horizontal was 0. So that's what we ended class with last time, right? And I asked you to see if you could graph that, right? So you did test points. What test points did you use? Again, -7, -2, +2, +5, +8. All right, and you have to take those numbers and plug those into the original function. And do you want to tell me what you got? Like at -7, did you get a positive or negative number?
Negative.
You got negative? Anyone else get negative? Yes? How about -2?
Positive.
Positive?
Yes.
How about at +2?
I got positive.
Positive as well. Yes, I think that's right. And then at 5, you got negative.
Yes.
And then at 8, you should get positive.
Yes.
Right, that's correct. And then you have to draw it, right? So to the left, when I draw it out to the left, I have to go towards this. So I just, that's fine. Just make sure you flatten out. Don't go across it, okay? Yeah, don't go down here forever. Just flatten out towards that. And then you have to just connect this dot to this dot to this dot. And then when you start trying to draw it to the right, you've got the vertical barrier in your way. So it's going to force you to basically go like this and go up. Are there any questions on that? What about this next point? What happens to the left? Are y'all okay? What's going on? Did y'all just not do it or don't know what happens or don't want to participate? What's going on? I know this table's answering, but everyone else is just kind of sitting there. Did y'all do it? You did it? Did you do it? Yes? So what did you do at this point? To the left? Went up, right? It has to go up. How about to the right? Went up, right? So it has to go, it almost looks like a parabola. I think, do I need to bring like a margarita machine or something to class? What do I need to do? Huh? Pizza every day or something? Shots, okay. We can do that. We need a little shot table over there. All right, that okay? It goes on both sides like this. Kind of weird, right? Goes up, but it does not come down here. It doesn't cross the x-axis. You only have 2 places, here and here. That's it. So then you go to this point and you draw it this way, and you got your vertical, which forces you down again. So you got to go down, down, and then here connect, and then you have to get flatten out towards this. Doesn't have to be exactly like that, but it's got to be, you got to have the same flattening out at the edges. You've got to have the same x-intercepts. You've got to have both going up here, this going up, that going down. That all should look the same for everyone's graphs.
So you always cross at the x-intercept and go towards the asymptote?
You always cross at an x-intercept and go towards the... Well, you don't necessarily always have to cross. There could be a case where I do a problem where I find an x-intercept here. Let's say this is a vertical, and this is a vertical, let's just say. And then I did a test point here and here. I could get this and this. And then I would have to come up, bounce off, and come down. I don't have to cross through. The only reason I cross through here is because I had to connect that dot to that dot to that dot. So I have to cross through to connect. I don't know if that's even what you're asking me.
Yeah, kind of.
Okay. Yes?
And about the vertical line test, you know how the lines that are close to the vertical line,
Yeah.
they go straight up?
Yeah.
Is that, what does that mean?
It's okay. They're not vertical lines. These things right here, they do get closer and closer and closer to this dotted line. They never get there, though.
Oh, okay.
So-
It's like a minuscule one.
Yeah, minuscule. We call it infinitesimally close. It's actually, there's an example that I remember, I think I was in 5th grade, my teacher did this. She said, okay, I'm going to start on one end of the room and I'm going to walk halfway to the other side, okay? And now from that distance, I'm going to go half again, right? And then I'm going to go halfway again, and then halfway again. Am I ever going to hit the wall?
No.
No, that's kind of the idea, is that you will get closer and closer and closer to this, but never get there. So you'll never truly be straight up. Any other questions on this? I gave you this one to finish, right? And then I gave you another one to try on your own? Do you all want to go through that one? Yes? You want to go through it? I always feel bad because I asked you to have it ready to turn in. So I want to give people who had it ready, like, the credit for doing it. If I do the whole problem, then everyone, even the people who didn't do it, are going to get credit. Does that make sense? So are y'all all right with that? Should I just do it?
Yes.
Yes? Everyone's all right? Okay. All right, so for the next problem, you're going to have to give me the problem because I don't remember what I gave you. Okay, x plus 6 over minus 9? Okay, this was the function. And I asked you to sketch this, right? So our first step is to do what? You have all the steps now, right? X-intercepts, right? So how do we find the x-intercepts? Set the, which part of the function? The numerator only. You only have to worry about the numerator. So set the top equal to 0. And that's a pretty straightforward equation, right? Just move this 6 over, subtract 6 on both sides. X is negative 6. Okay, on my graph, that's a point on the x-axis, right? That's a point I'm going to draw. Second step. What's the second step for graphing rational functions? Vertical asymptotes. How do you solve for those? Set denominator equal to 0. Okay, so x squared minus 9 equal to 0. All right, for x squared minus 9 equals 0, you should recognize x squared minus 9 is a difference of squares. And then that should trigger you to, trigger you. No, that should get you to want to difference of squares this, right? And then from there, set each of those equal to 0. And so I'm not going to show this, but we'll get two answers, right? Negative 3 and positive 3. Those are not points on my x-axis, right? Those are vertical dotted barriers. Third step, horizontal, right? And this is where we have to do what? For the horizontals, or for the horizontal. Compare the degrees, right? To compare the degree of the numerator and denominator. What's the degree of the numerator? 1. What's the degree of the denominator? 2. Okay. In that case, the numerator degree is smaller than the denominator's degree, right? And what case was this? I gave you 3 cases, right? This was case 1. And I have not done case 2 or case 3 yet. I haven't shown you all those yet, right? That's what today is about. So this is case 1. What does case 1 tell you when you have numerator degree smaller than denominator? What's your horizontal asymptote? Horizontal asymptote is y equals 0. And remember, the horizontal asymptote only tells you what happens at the edges of the function. It's that dotted line at the edge that's going to pull your graph towards it. That's all it is. All right, 4th step. What's the 4th step? Graph everything that you have over here, put it all on a picture. Starting with the x-intercept at -6, I'm going to put a dot at -6, and I'm going to do it with a blue. -6. That's part of my graph. Then I have 2 verticals, right? One at -3, one at +3. Those I'm not going to do in blue because I don't want to confuse those with my graph. Here's -3. Here's +3. Yes? What else now? Horizontal, right? Where am I going to draw that? Y equals 0 is the x-axis, right? So draw it all the way across? No, right? Is it only at the edges? Here, here. That's the setup of the problem. That's everything I need to now do the 5th step, which is, what's 5th step? Test points, right? We have test points now. How many test points will I have? How many test points? What's that? I couldn't hear you. 4, thank you. Test points, 4. How are you determining 4? What are you doing to determine 4? How many of these do you have, right? You have 1 of these, 2 of these, that's 3. And so it would always be 1 more than those added up. And I said ignore the horizontal, right? Just ignore that. Just count how many of these you have, and then add 1, that's 4. So we're going to have 4 test points. So it's not just 4 test points anywhere. You have to make sure you get the information where you need it. So I need to know what's happening over here, 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 and here. So I've got something, first test point there, second test point here, third test point between here and here, and 4th test point over here. Any number I want over here, what do you want? -8. Good. Okay, how about right in there? -4 would work. Anywhere between here and here. Now, look, this is just the y-axis, so you don't need 2 test points here. You just need 1. So what's a really good number in there? 0, right? 0 is a good number. And then something to the right of 3. Anything you want. 5. You remember in class I said that what I like to do with my test points is I like to put little x's on the x-axis so that I don't accidentally think that they're x-intercepts. I also circle them so that I can distinguish them from other things. It's just so I don't mess myself up. All right, what are we going to do with these test points? -8, -4, 0, and 5. What am I doing with these? Plug them into the function, right? And when I told you plug them in here, you can just plug them in, but I told you there's also a shorter, not like kind of, I don't know, I like doing it this way, where I rewrite this function in its factored state or factored form, right? And we've already factored though, right? We've already done this here. So all we're doing is rewriting the bottom that way. And then instead of actually trying to grind out what the actual number is, I'm just going to figure out what the sign is. It's either going to be positive or negative, depending on the number I plug in. So watch, when I plug in -8, what happens when I plug in -8 up top? I get negative, right? So I have a negative on top, divided by, and if I plug in -8 here, I get a negative number still, and then here it's -8 minus 3 is still negative. So I have two negatives on the bottom being multiplied, right? Two negatives multiplied to be positive, and a negative divided by a positive is negative. I like this way because now what I know is that at -8, I should have a point below the x-axis. So I'm just going to come over here, anywhere I want below. Boom. I'm going to do it in blue. That point's on my graph. And I'm going to do that for each of these. I'll do one more. -4, if I do that, what do I get if I plug -4 into the top? -4 plus 6. Positive. And then how about the bottom left corner? -4 plus 3. Negative. And then the last one, -4 minus 3 is -7. So we have a positive on top, two negatives multiply to be positive. Positive over positive is positive. And so that means that at -4, I have a point above the x-axis. And then I continue doing this, right? I just continue doing this. And if you do it, what you'll determine, I'm not going to show the work, is that at 0 you should have a negative, and then at 5 you should have a positive. We don't care about how high and how low these points are. We don't care. Even with polynomials, remember the functions we did before this when we had all those ups and downs? We didn't know how high they went. Same thing here. We don't care. We're just trying to draw a rough sketch of the function. All right, I'm ready to draw it now. Starting at the leftmost point, out this way, where do I go? Towards this, right? The horizontal. So just go like that. And then from here, connect to here, connect through, right? We're going to cross through. And then I've got this vertical barrier in my way, so that forces me up. Then I have to jump over, grab my next point, which is here, draw it to the left. What, go up? Down. Can't go up, right? Can't cross the x-axis. So I have to go down. And then to the right, up? No, right? Because I can't cross the x-axis. So I have to go down. So it's going to look, again, almost like a little parabola in here. That goes down. Right? And then on this side, to the left, I've got my vertical, forces me up, right? Can't go down, can't cross the x-axis. And then here I flatten out. There it is. Any questions? These kind of suck, right? I mean, they take a long time. There's a lot of work to do. But, all right, when you look at your, could you please look at your notes? What was case 2? Can someone tell me? Because I said case 1 is when the horizontal asymptotes. I said case 1 is when the numerator is smaller than the denominator. What would I say for case 2? Bigger? Okay, let's do that. Let's do one of those. So first thing I'm going to do, and I told you last class when you were taking your notes to leave space so you could come back and fill in what happens for case 2. For case 2, if your numerator's degree is bigger than the denominator's degree, if that happens, then you have no horizontal asymptote, which means that your graph does not get pulled down at the edges. It doesn't happen. All right? What happens instead is this. The left side of the graph will go up, or it could possibly go down. We actually don't know which it is. And then in the middle of the function, we don't know. It could do a bunch of crazy shit. And then on the right side, it's either going to go up or it's going to go down, and I don't know which one it is yet. So this is another way of saying that, look, if this happens, case 2, You have no flattening out at the edges, so it's either up forever or down forever on the left and the right. We'll have to figure out which of these it is. It can't be both though, right? It can't go up and down, because then it would fail the vertical line test. Right? So it's got to be either this or that. And then over here, it's got to be this or this. So let's just do an example. You'll see. So how about we do x squared minus, let's go with 4x minus 12 over x minus 3. I want us to sketch this rational function. Y'all remember what I said about this, right? Like, you're never going to graph a rational function ever again, right? That's not what this is about, right? This is about a procedure. This is, can you follow some sort of analytical process without making mistakes? So, step 1. X-intercepts. Set the top to 0. That's a quadratic, right? When it comes to quadratics, you have two options, right? You can either factor by AC method, or you have the quadratic formula, right? Right. Do y'all mind taking that and just slide your whole thing down just a foot? That way you'll have a little more, there you go, a little more breathing room there. All right, so AC method or factor, quadratic formula. This, I think we can factor, right? I set it up so it can factor. What are the factors? -6 and +2. Okay, so I'm not showing that work. I'm trusting you could get that. And that gives us two solutions, right? 6 and -2. All right, those are points on the x-axis, right? Those are points on the x-axis. Second step, vertical asymptotes. Set the bottom to 0. Easy money. X is 3, right? Just move the 3 over, or add 3 to both sides. We still good? All right, thank you. Horizontal asymptote. Well, the degree of the numerator here is 2, right? Oh, my goodness. 2, right? The degree of the denominator is 1, and therefore the degree of the numerator is bigger than the denominator, right? So numerator's degree bigger than denominator's degree. This is case 2. That's case 2. So that means we have no horizontal asymptotes. So it's going to do this or this. So we're never going to draw a dotted line horizontally on this graph. But we still do need to remember that this happens. Either this or this or this or this. So we can move to the fourth step now, which is to put everything on a graph. Starting with the x-intercepts, I have one x-intercept at 6 and another one at -2. These are dots on my x-axis. Am I moving too fast or am I doing okay? Okay, speed-wise here? Can we speed up? Slow down? You're okay? What next? Vertical, right? At 3, we have a dotted vertical barrier at 3. And that's it. That's all I know. This is all I know. But, you know, I don't have this magnet thing on the edges. I just know that this tells me that on the left side it's going to go up or down, on the right side it's going to go up or down. All right, how many test points will I need? How many test points? 3. 3? 4? What? 4. I have 2 x-intercepts. I have 1 vertical. That's 3 total, right? And then add 1 to that, you get 4. So I'm going to need 4 test points. And the 4 test points, you know what? Let me do this. Before I do the 4 test points, I'm going to actually rewrite the function over here. I'm going to write it in its factored form. Right, so I went ahead and took this factored version of this and just put it over there because I'm going to plug my test points into it, so I want to be able to see it. Test points, I like maybe like -4, I don't know. What else? What's a good one? What's a good one between here and here? 0, right? 0. If you can ever plug 0 in, try it. 0 is always nice. And then, what else? Ooh, wait, hold on. Where else do I need another one? 8 would work. I need 8. Yes, 8 could work, but I'm missing one. Where's a place where I don't know what's happening? 4, right? Between the 3 and the 6. Between here. I need one right there. How about 4? So my test points, I need to plug in -4. I need to plug in 0. I need to plug in 4, and I need to plug in 8. Let me try the -4 into this. So -4 take away 6, that's a negative number, times -4 plus 2 is still negative, and then -4 minus 3 is negative. 2 negatives on top is positive over a negative. Positive over negative is negative. You see how I'm working through that? It's like it's a little faster than like actually trying to plug the number in, and there's less. I think there's less room for error, because when you go and like square negative numbers and people make mistakes. So let's see. What about 0? 0 is kind of a strange one to plug in here. 0 take away 6. That's -6. Times 0 plus 2 is 2. That's positive. And then 0 take away 3 is -3, so that's negative. Negative times positive is negative. And on the bottom still negative. 2 negatives divided is a positive. Are you happy? You're not happy. Don't tell me you're happy. You following? Yes? Okay. All right, I'm not going to do the next 2. But I would get negative. No, sorry, negative, positive. Sorry, this last one's positive. I apologize. So this one does switch, negative, positive, negative, positive. And I told you last class that you can't trust that it's going to switch each time. You have to actually test it. And the one I did sent you home with, right, it didn't switch. There was one that didn't switch, so. All right, so at -4, I put a dot where? -4, I put a dot down, right? And then at 0, I put a dot up. And then at 4, I put a dot down. And then at 8, I put a dot up. And somehow we're going to be able to get a picture here. So if I go to the left, right? If I go to the left, what happens? Yeah, so it's not going to flatten out to anything, right? So it either goes up or it goes down. Why can it not go up? I would cross the x-axis, which means I'd have an x-intercept somewhere where I'm not supposed to. I'm only supposed to have an x-intercept here and here. So when I'm at this point, I know it's either up or down, but because I can't cross, I must go down. So I know it's going to go down, right? It's going to go down just like a polynomial, like down. And then here, I connect dot to dot, and then vertical gets in my way and forces me up. I'm not really talking about this anymore. I mean, I'm assuming you're okay with the idea that it can't turn back because there's no x-intercept, right? Pick up my pencil, go to the other side. Here, let's look at that point. To the left, it's kind of tight in here, but to the left, barrier, right, forces me up or down. I have to go down, though. So I'm going to go down here, connect, right? Let me go ahead and do that down here. Connect, and then once I get here to the right, it's either up or down. Which one is it? Not because it looks like it, right? It's because I can't come back down, right? If I come down, I'll cross the x-axis. So it must mean I go up. Yes?
Would there ever be like one where both of them, like the second little line, would turn back and go towards the vertical asymptote?
Like this?
Like, is it ever going to do that?
No, because if it turned back, let's say it did, it would fail the vertical line test, right? So you wouldn't have a function anymore. So with what we're doing, no. There are curves in the real world that would do that, but they aren't functions of x. They're something else, which we don't study in here. So, all right, good. Case 2, understand? All right, case 3 is the weirdest one. All right, let's look at case 3. The good news is we're almost done. Case 3. This is when the numerator's degree equals the denominator's degree, right? I'm going to give you a few examples of this, all right? Before we even tell you what happens, I'm going to show you a few examples of what it would be to have a function where the degree of the numerator and denominator are the same. So here's one example. What if we had 3x squared minus 27 over x squared minus x minus 30? Okay, that's an example where they have the same degree, right? You'll see they have the same degree. Here's another example. F of x equals negative 2x plus 1 over x minus 4. Same degree, right? Top and bottom. I'll give you one more. F of x equals, how about, x cubed plus 1 over x cubed minus 9x squared. You know what? Let's make it 2x cubed minus 9x squared. So what I'm doing here is just making sure you understand what it means to be in case 3. The degrees here are the same, right? 1, 1. Same degree. Here, 3, 3. Yeah? In this case, here's what we get. We have a horizontal asymptote. Our horizontal asymptote is y equals, so you know in case 1 it was y equals 0, which was basically the x-axis, right? It was just a horizontal line, 0. You don't go up or down, just horizontal line, right? Here we're going to have a